Yeah, these things normally take a few seconds for them. Yeah. All right, looks good. All right. Thank you, Bob. Thank you for coming. Really appreciate your time. I hope this is a fun discussion. I hope people take something from this. And yeah, just let me just start off by saying, who is Bob? My first question. Who is Bob? Right.
Well, thanks for inviting me. Who is Bob? Yikes. I am a programmer. I've been a programmer since 1964. Although I wasn't hired by anybody then. That was when I first started knowing that I wanted to be a computer programmer. I wrote my first program back then. And so I've been a programmer ever since. I have written in mostly assembly language in the early days, finally went to C by the 1970s, C++ in the late 80s. Java after that, and nowadays I write mostly in Clojure, which is just Lispy language that runs on top of the Java stack. I've written lots of systems, embedded real-time systems, financial systems, computational geometry systems, heavy-duty graphical user interfaces. It's been a long career. And I've done an awful lot of things, and of course, the career's not over yet. So,
of course, yes.
By the way,
even in the present
day, you have me on my 67th birthday, and I just got off of an airplane where I did my 1,000th landing.
Amazing! Wow, happy birthday! Even more appreciated of your time. So, thank you again. Awesome. Just out of curiosity, where did the name Uncle Bob come from? How did that come about?
This came about in 1987 or 8. I was working at a company called Clear Communication in Illinois. It was a startup. And it was a startup that never really managed to go anywhere, as most startups don't. There was a fellow there who gave everybody nicknames. And I was Uncle Bob. And he was an annoying kind of fella. He would walk around going, Uncle Bob, what about this? Uncle Bob, I need your help, Uncle Bob, Uncle Bob. And, I found it grating and annoying. And I eventually left that company and began consulting at Rational on the very first release of Rose. And no one was calling me Uncle Bob. And I started to miss it. And so I made the mistake of putting it in my email signature. And I was starting to get pretty well known on the internet in those days. We had our own little social media thing called Usenet back then. About a year or two later, I was at a conference and somebody waved me down and shouted out, Uncle Bob, Uncle Bob. And I thought, oh my God, I've created a nightmare here. I've got to stop it. And I ripped it out of my email signature, but it was too late. And everybody started calling me Uncle Bob. And at some point, I realized that it was a reasonable brand. So I've been using it as a brand ever since.
Okay, cool. And do you prefer people to say Bob or Uncle Bob, or are you just indifferent right now?
Bob is fine. Whenever we're talking, I prefer Bob. People, when they walk up to me, will say, are you Uncle Bob? I've had that happen a few times.
Okay.
And, if it's something where we're addressing each other formally in front of an audience, then Uncle Bob might be the more appropriate brand. But Bob is fine.
Cool. Awesome. And actually, obviously, you've done a few YouTube videos, you've done many courses. And one talk that you've done a few times that's quite interesting is when you talk about the future of IT.
Yes.
And you go on by talking about the history, and then you come on to your premise. And what I want to do is kind of break down a little bit of what you talk about in your discussion about the future of tech and the history. And
Sure.
I want to first of all start off with, so you kind of begin talking about the early stages, the pioneers kind of in computing, and a lot of them were women. You've got Ada Lovelace, you've got other people that you've got that basically were pioneers. And you talk about the statistic of how basically women were pretty much eradicated throughout the history of computer science. The numbers were dwindling. What do you put that down to ultimately? And is there a way to bring that back up? Like, how do
So
you assess that?
this is fascinating. So the early days of computing, women were programmers and men were not. Men built the hardware, and programming was considered a kind of clerical function. And so clearly you wanted women to do that. At least that was the mindset of the day. When I started programming as a job, when I got my first job programming, the year was probably 1968 and or 67. And the company I worked for had about, I don't know, 20, 25 programmers, something like that. Not quite half of them were women. And by the way, all the programmers were old. They were in their 30s or 40s or 50s, including the women. I was 18 at the time. I was young. So that would have been, it's 1970 probably. And I was like the youngest programmer there. That changed. It changed within about 10 years in my experience. By 10 years later, I was working at a completely different company. There were 50 programmers and 2 women. And the women were all young. They were out of school. And all the programmers were young as well. They were all out of school. The oldest programmer was not yet 30. That was probably me. This demographic shift happened very rapidly. Now, if you look at the curves, there's a number of curves that you can see online of people charting, when women started to not become programmers. And those curves seem to put it around 1983. But in my experience, it started much sooner than that. It was mid-70s, when it happened. Now, why? Why did this happen? I haven't got any idea why it happened. There is an event, however, that might coincide. The programmers who were programming when I first got my first job, these old people that were, half women, half men, did not go to college to become programmers. They didn't take a computer science course. There weren't any. But computer science courses started turning out programmers in the early to mid 70s. And most of the graduates were men, or boys, I should say, because they were all, 20 or 21 or 22, coming out of school. So something happened on the educational side of things. And why, I don't know. One person has a theory that it was the advertisement of personal computers, and that the advertisers were advertising them to boys. I don't buy this, because that would make the demographic shift happen in 1983 or 84, and I saw it 10 years earlier. So I don't think it was that. I think it was something else. And what it was, who knows? Something about the way the colleges were attracting and turning out graduates. But after that, I'm lost. I don't know what caused it.
And do you feel like there's something that can, reverse that effect? Do you see anything in the future or currently that can bring some more women into the tech industry?
The answer to that is difficult for me, because I don't know what caused it in the first place. What caused this demographic shift? And it's not at all clear to me. Something in academia, probably. Now, what's going to reverse it? I think I know what's going to reverse it, but it's not the answer most people like. Most people want some kind of proactive, we need to prefer women, we need to, whatever. I think it would be a good idea to hire women, but what's going to reverse it is just sheer demand. The demand for programmers is enormous, and right now it's all men. Well, we're going to run out of men. We're currently ignoring half the population of the planet to satisfy this enormous demand. And so long as the demand keeps up, the industry is going to have no choice. It's going to have to hire the women who have the aptitude. That means that there will be a stronger draw, a pull, not driven by any kind of need for diversity, but driven instead by sheer demand And that demand is going to eventually filter out to the schools, and the women will be brought in that way. That's probably the most reliable mechanism. I know some
Sure.
folks want to have quotas. Some folks want to have enforced hiring of exactly 50 women. I don't think that's either workable or even wise. Somehow we're going to have to get the women to really get into the pipeline and want to be programmers.
What is your view on diversity then? Do you feel like diversity in terms of the tech industry is a good thing, or do you feel like it's indifferent, or do you feel like there's other factors that are more important in terms of the tech industry and diversity?
I think when you make diversity a goal, you're focusing on the wrong thing. I think diversity should happen naturally. Now, it doesn't right now. There are factors in our society that screw up with what ought to be happening. But in an ideal world, if you selected only for talent, you would get a very diverse group, right? Because if that's the only variable you constrain, all the other variables are free. That's where I would like to see it. I want to be able to live in a society where we select for talent and diversity happens naturally, and we don't even think about it. The society we do live in has to somehow put its thumbs on the scales, and I hate that. I hate putting my thumb on the scales, because then we're selecting for the wrong things. Now, I understand why there may be a need for it, but it doesn't make me hate it any less.
Yes, yes, yes. Yeah, I mean, I see the value in diversity personally just because I feel like when it comes to different people, women in tech, black people, all sorts of people in tech, I think it actually brings a different perspective. Suppose when you program, essentially we're like human beings who program something, and especially when we're in industry, programming for different people. I think that diversity actually does help in terms of actually getting the finished product and the correct product, because you've got different perspectives on things, different approaches. And at the end of the day, we're coding for people in those organizations. So I do see the value in diversity equally as well. So it's definitely it's an interesting topic, I think, and I think it's one that we can definitely dive into for like this whole duration of our talk.
The diversity argument is a fascinating one, because it depends on the idea that there are differences, right? There's differences between men and women, and black people and white people and Hispanics and transgender. There's differences. If there weren't differences, there'd be no need for diversity. And yet, there is this very massive social push to declare that there are no differences. So there's this inbuilt contradiction in the whole system here. Are there differences? Are those differences valuable? If those differences exist and if they're valuable, don't they also mean that people will have different interests? Might it be that some people who are different in one way simply don't want to be programmers? It's a fascinating time that we live in, and one that is fraught with social peril. And I don't know how to continue from that. You're right. We could fill up the entire hour.
It's interesting. But yes, we can, but we won't. I'm
Okay.
going to shift back into the future of IT because I actually do want to get to your premise at the end of it. So I want to actually talk about the late 60s, 70s. So this is the time you're talking about with a lot of the students and younger people coming in. And I want to talk about the idea of how structure was starting to come in, talking about things like object-oriented coding, like methodologies such as Waterfall. Like, talk a bit about why that came into the fold, and yeah, just talk about that a little bit.
Initially, programming was just programming, the writing of code. Early programmers had no concept of structure at all. It was just 100 lines, 150 lines, 200 lines. In those days, those were big programs. programs started to get bigger and bigger. They'd start approach, 500 lines, 600 lines, 700 lines. And it became clear that some kind of structure was necessary. And so was born the concept of modular programming. And like all concepts in software, it was immediately bastardized and screwed up. And people started making ridiculous rules like no module should be longer than 500 lines or 500 bytes. That's an even better one, because back in those days, we measured code in bytes. And people would say, okay, we're going modular now, and so modules can't be any longer than 500 bytes. And so programmers would write 500 bytes of code, and then they put a jump statement into the next module to continue their code. Just absurd. We started to get a little smarter about this in 1966, 67, 68. This is when people like Ole Johan Dahl, Christian Nygaard, Tony Hoare, Edsger Dijkstra were really starting to feel out what programming was, what the art of programming was. They wrote a lovely little book, these guys. Let me see if I can get it for you. You're recording this on video, aren't you?
I am.
Okay. Yeah, here it is. Okay. Structured Programming, 1972. It's out of print, but you can still get copies. This is the book in which Dijkstra says GoTo might not be such a great idea. This is the book in which Ole Johan Dahl talks about how he and Christian Nygaard invented the first object-oriented language ever. It's a fascinating book. And if you read through it, you will see these beginning ideas of how software can be structured and organized and what the principles are. They didn't name principles. They didn't have, the solid principles. They didn't have that back then. But there were hints, little hints peeking out from this wonderful, wonderful book. If you can get a copy, if your viewers can get a copy of this book, get a copy. It's fascinating reading. All of this stuff was in the late 1960s, from about 68 until early 70 something. Dijkstra came along and said, well, gee, GoTo might not be such a great idea. And his premise was that code should be provable. And he showed mathematically that if there are unrestrained GoTos, you can write modules that cannot be proven. And so his idea was, all right, we're not going to use unrestrained GoTos so that we can prove our code correct. Of course, nobody proves their code correct. But it turns out that the same rules mean that you can reason about the code. Right? If you can prove it correct, then you can reason about it. And if you can reason about it, that's a very good thing. And so we continue on with structured programming today to the extent that our languages have taken the go-to away from us. If you're a Java programmer, you don't have a go-to. And if you're a C# programmer, you don't have a go-to. Our languages don't allow it anymore. Dijkstra's rules have become something we don't even think about anymore because the languages enforce them. A little before that, Ole Johan Dahl, Christian Nygaard in Oslo were fiddling around with Algol 60. Now, Algol was a very primitive language, very old language. It was the language that followed Fortran. And to write 1,000 lines of Algol would have been very difficult to do. The machines just weren't powerful enough to handle that kind of a program. And these two guys, fiddling around with the language, moved a few things around and invented objects. And it just kind of happened to them. And the story is in here, and the story is fascinating about how they did it. And all of a sudden, objects were born. This is like 1966. And they finally solidified it into a language called Simula 67, which was a derivative of Algol. And that language was a language that was taught in universities, especially in Europe. And one guy who learned that language very well was Jarne Stroustrup. Jarne Stroustrup then got hired in the late 70s by Bell Labs, and they showed him C. Well, he didn't want to program in C. He wanted to program in Simula, and so he wrote a little preprocessor in front of C that made it look like Simula. And sorry for all the dings. That's all
Yeah,
birthday.
yeah.
You know,
Yeah, what's
birthday
going
whips
on?
are coming in. I'm going to shut them all off here,
Oh,
so it's not interrupting us. Let's see, notifications, do not disturb. Let's see, yeah, right there. Good. Okay, so they won't ding anymore. I hope. I've got too many devices around me. One of them
I
might
can
still.
see, I can see. You've got a pretty cool
Yeah,
sound.
yeah,
Yeah.
that's the flight simulator back there. Right?
Oh,
You
okay,
know,
yeah.
there's an iPad, so it's probably going to ding, and they got an iPad sitting in front of me that you can't see here, but there it is. Yeah. So I'm surrounded by screens. A typical program.
Devices. Wonder how many processors you've got in your room.
Yeah. Hey, see the little one back here? That little
Yeah.
here. You see that one? Little blinking away. That's my mock-up of a PDP-8. It's actually got a
Oh,
Raspberry Pi in it,
oh, sweet.
running OS 8, I think.
Okay.
So you got these guys, right? They invent objects. SkillStruct writes this preprocessor in front of C. He calls it C with classes. And about 3 years later, by 1983, one of his friends said, "Hey, you ought to call it C++ instead." That was the way objects crept into our industry, and we really didn't know what that was for. The two guys, Ole Johandahl and Christian Nygaard, they said, "Well, it's a better way to present abstract concepts. There's things you can express using this object stuff that you can't express any other way." Maybe that's true. I'm not sure. We went down this very long pathway for probably 15, 20 years where we thought that objects were really about modeling the real world, and I've kind of given up on that. I think no, that's not why we do objects at all. The reason that object orientation is really beneficial, and it is very beneficial, is because of the way it allows us to control dependencies, and it does.
Control what, sir?
Polymorphic behavior allows you to
Oh, okay.
control the way dependencies point. So if you're using an object-oriented language, you have absolute control over every dependency in your system. And so that was something we never had. Prior to that, all dependencies were dictated by flow of control. If A called B, then A depended on B. And with objects, if A calls B, B can depend on A. It's a wonderful thing. So
And
this is how structure kind of got into the industry. And based on just those two stories, imagine the background. In 1968, how many programmers were there?
not a lot.
Not a lot. No, a few thousand in the world. How many computers were there? Maybe 1,000 computers in the world. And now, of course, the number of computers is enormous and the number of programmers is enormous. But all of that early learning, all those early rules took place at a time when the population of programmers was impossibly small and about half women. And then there came this massive demographic shift, which coincided, by the way, with a technological shift. And that's something that we haven't talked about, going back to the diversity argument. What did the big, huge technology change? You know, the shift from vacuum tubes to transistors and from transistors to integrated circuits in a period of 10 years. What role did that play in the crazy demographic shift that we've seen in this industry of ours? I don't know, but it must have been something because it coincided so well. In any case, you've got these ideas, structured programming, object programming, functional programming, that were all invented long before the big demographic shift. And then all of a sudden in the 70s, before these ideas had time to actually gel anywhere, they're just almost barely there. Right? This book had only been published in 72. Most people hadn't read it. Most people haven't read it today, most programmers, right? And all of a sudden, there's this massive influx. People are just pouring into the industry. They're all stupidly young. They're coming right out of school. They're all in their 20s. They believe they're going to conquer the world. And there we are. And this lasted, well, I mean, this is still going on today. Right? The influx of young people into the programming industry outpaces everything else.
Yeah.
I've done the math a million times with a whole bunch of different audiences, but you know, the population of programmers doubles every 5 years, which means half the programmers in the world have less than 5 years experience. There is no way to teach the incoming young people everything that the old people know. We don't have bandwidth to do that. So it's a very, very interesting time in our industry, and one that is headed for significant troubles, I think.
Interesting. I know we're creeping up to your premise, but I want to pull back a little bit and talk about the structure aspect.
Sure.
So from that aspect, structure is important, right? So
Yeah.
we've got things like we talked about object orientated. What about things like Waterfall and Agile? And you know, obviously, Waterfall is obsolete right now. It was quite popular in the 70s for whatever reason, but now we're using things like Agile, which is something obviously you know a bit about. Talk to me about that process and how Waterfall came about and Agile, that sort of shift in mindset.
So when I started programming in the late 60s, early 70s, we had no process at all. No one even thought of a process. Right? It was like, write the code. just write the code. There was no process. And I remember reading a trade journal. In those days, we actually had print magazines, you know, trade journals that we could read. And I remember reading a trade journal about this idea that you could analyze the requirements for a period of time, and when you were done with that, you would be done with something. And then you could design the system that would solve those requirements. And when you were done with that, you'd be done with something else. And then you could take that design and implement it in code. And what that gave us was this 3 milestones, right? The end of analysis, you could put a date on that. And the end of design, you could put a date on that. And then the end of implementation, you could put a date on that. And it was a godsend. I remember reading this and thinking, well, of course. Why? How could we not have known this all along? That's the obvious way to get things done. And everybody else felt the same way. And so we started this idea. We started to try to come up with an analysis. Now, one of the problems there is that we had no idea what the output of analysis was. So we fiddled around for a very long time trying to figure out what the output of analysis was. And no one ever came up with a reasonable solution to that. It was like, okay, you know, well, maybe it's a flow chart. Flow chart's probably not good enough. Maybe it's a data model. I mean, that's not good enough. We went over and around this stuff. Books were published on it. One of the best books out there. Still a great book, by the way. Let's see if I've got it up here. There's structured design. And where's the other one? It's right. Oh, here it is. Books from the 70s and 80s, right? This one is Tom DeMarco's Structured Systems Analysis, where he tries to describe what the analysis of a system might look like. And actually comes with a bunch of very good ideas. I don't know how many people read this book, but it's a wonderful book. And here's a similar book written a few years later. This is about structured design, how you would take the analysis and turn it into a design. So fascinating ideas, and we all thought, yeah, this is the answer. This is what we need, and we tried to do it.
Sorry, I'm just conscious that your cupboard door's open, and I don't want a YouTube moment where you just
when I bang my head.
Yeah.
Well, that wouldn't be the first time that's happened. So we tried to do it. You know, we tried to follow these rules, and we had some success. You know, it wasn't like it was an abject failure. We had some success at it, not great success. Like the dates never were. And the analysis was never quite right, and the design was never quite right. And by the time we got to writing the code, and things didn't fit very well, but it was tantalizing. It was always, well, maybe if we did it a little differently, we could make it work better. So we went through 30 years of this, 30 years of trying and trying, and nobody had a better idea. Barry Beam came along with the spiral approach a few years later, but everybody looked at that and said, well, it's just waterfall in circles. So sometime around 1995, that's when the real change started. And this is significant. The big demographic change happened in the early 70s, I think. So by the mid 90s, about 20 some odd years later, all these young 20-year-olds who had gotten involved with software in the 70s were now in their 40s. And they're all looking around going, man, we've been trying this for so long and it just doesn't work right. There's got to be some better way. And a few people started writing papers. So you saw the Scrum paper come out in 95. Yeah. And Alistair Coburn started writing papers about the Crystal method. Jim Copleen started writing about the patterns of successful companies. And he showed that Waterfall was not one of the successful patterns, that there were better patterns to follow that looked a lot more like Scrum and Crystal. By 98, 99, Kent Beck had come up with this extreme programming thing, which I think he named because of extreme sports. Back in those days, people were jumping out of helicopters with ski boards on. And it caught my attention. The extreme programming thing in particular caught my attention. I thought, yeah, there's something to this. And bit by bit, we all got together, and there came this meeting when we all called it Agile. A whole bunch of us got together and said, yep, Agile, that would be great. And we had this meeting, and we wrote up a little manifesto, and we all went home, and we thought that would be the end of it. And that wasn't the end of it.
Really? Understatement, yes. Yeah, fascinating. And now let's talk a bit about the future, as in things like artificial intelligence, things like driverless cars. Do you keep an eye on these things? Like, what's your thoughts on all of these things? Like, are you like, wow, this is fascinating, or you're like, this is too fast? Or what are your thoughts on some of these new technologies that you're seeing?
It's important, I think, to understand that I grew up in this industry during a time when the technology was going through wild and crazy changes. Moore's law was in full effect, right? Computers were getting faster on an exponential scale. Right? Every 18 months, clock rates would double. Every 18 months, density would double. The capacity of disks was doubling. The capacity of memory was doubling. We switched from core memory to solid state memory. These changes were enormous. This little machine behind me, this PDP-8, right? It's a fake PDP-8. Is many times faster than the original PDP-8, even though it's running a little Raspberry Pi there and it's simulating PDP-8 code. Most of us grew up on this exponential curve. And that exponential curve has a momentum to it. You could feel it, right? You buy a laptop, and you knew that laptop was going to be out of date in a year. You'd have to buy a new one. None of the software would run on the older ones, right? So you were in this cycle. You knew things were going to get better and better and faster and faster and denser, and there was no stopping it until 2003 when they hit a brick wall. Bam! And the clock rate stopped dead. And the density went on for another couple of years, and then that stopped dead. But we all still feel the momentum. We all still think that computers are going to get better and better and better, and they're not. Computers are not going to get better and better. Disks are going away. Memory is not going to get infinitely more expansive. Everything that we've already reduced the cost of processors and the cost of memory to virtually zero, there isn't a lot of room to get better. And so we have these dreams. We have dreams of self-driving cars. Now, I mean, they're not self-driving yet. We've got some cars that can kind of drive on the road as long as it's in very constrained environments and as long as the weather is good. But in a few years, it's going to be there. No, it's not. No, it's not. Right? Because the massive progress in technology stopped. People talk about, artificial intelligence. AI is going to take over the world. People's jobs are going to be at risk because anything that a human can do, a computer will be able to do. No, that is not going to happen. The computers are not getting better. The clock rates are not increasing. The memory capacities aren't growing like crazy anymore. Now you can get a 2 terabyte machine, but I could get a 2 terabyte machine 8 years ago. So we're experiencing this momentum of the past, and it hasn't plateaued the way that the technology has. This is an uncomfortable message to deliver. Nobody wants to hear it. But I think it is the truth. I don't think we're going to have self-driving cars that are utterly general purpose. We might have very constrained areas where self-driving cars run, as long as you don't let 2-year-olds run into the street. We might have trucks on the highways, trucks on the motorways, because that's a very constrained environment, as long as they don't take any of the exit ramps. But beyond that, I don't think we're close to truly self-driving cars. I am more concerned about autonomous robots used in combat than I am about self-driving cars.
Okay, can you expand on that a bit? That's interesting. Why?
So autonomous robots, as long as you can have humans controlling them, giving them general orders, the autonomous robots can pick their way across landscapes and probably identify targets as long as the humans are there to bless those targets or officially say, yes, go ahead and attack those targets. So I think it would be possible to create an army of autonomous robots.
Are we talking about...
And control them with humans? Very much like we have drones in the air right now that are controlled by humans thousands of miles away.
Yeah, so I was going to say, are we talking about robots we see in the movies, or are we talking about drones that are used in everyday combat now?
Yeah, have you seen those? I'm not talking about flying drones here. Have you seen the Boston Dynamics videos they do with the little robot dogs and the little robot horses?
Oh, okay, yeah.
That's pretty powerful stuff. And you can imagine, an army of 100 of those or 1,000 of those with commanders, human commanders, direct. And that's a scary thought.
Yeah. And we're kind of touching on the power of technology a little bit here. And I kind of want to talk a bit about social media.
Sure.
What are your thoughts about, let's talk about the internet, social media, and this idea of censorship versus the element of control? Like, what are your thoughts in this? Because I know you're one for, without giving the premise away, there has to be an element of some guidance in what we're doing. Whenever there's like the wild, wild west, it's going to get to a point where, we're going to hit the ceiling, as it were. So what is your thoughts about, the internet? Is it good for social media? Is it a good force? Is there any way to control it? What are your thoughts?
The smartest person who ever lived was Douglas Adams, I think. And in Hitchhiker's Guide, he wrote of the Babel fish. The Babel fish, you put it in your ear, and it would translate any language from any alien society into something you could understand and back again. And let's see if I remember the quote possibly. By effectively eliminating all barriers of communication between species, the poor Babel fish was responsible for more and bloodier wars than anything in history. The internet is the Babel fish. It allows people to communicate in an almost completely unconstrained way. I view this as a good thing. I think it is good for people to communicate, although it does seem to start more and bloodier wars than anything in history, although the blood is metaphoric. I don't want there to be drives to censor the internet. I don't think it's wise, for example, for Twitter to say we're not going to have political advertisements, because who is going to decide now what is a political advertisement and what is not? Who at Twitter is so wise to make that decision? I do not think it is wise for Facebook to try and scour away hate speech, because who decides what hate speech is? Who is so wise that they can determine what hate speech is? I think the level of censorship ought to be limited towards things that are truly illegal. Right? It is illegal for me to command other people to kill someone, or to literally incite violence. That would be illegal, and that ought to be removed. Anything else? I'm very, very reluctant to suggest that anyone is wise enough to decide what should be pulled down and what should be allowed. That looks to me like the first step towards real difficulties, real serious difficulties.
And for the people on the other side of the argument who might push back and say, clearly there's a problem here with, I don't know, like trolling and all these other things that come from the internet. Clearly there's good things, but there's this side of it. Is there anything practical that you can suggest that maybe isn't just essentially, you know, it's better than, it's the less of two evils, essentially? Is there a practical, a pragmatist approach to this, or is it either you're for the internet fully, social media fully, or you're not? Like the good, bad, and ugly.
Yeah. So I come down on the side that I want as little censorship as possible. If it's legal, if it's not strictly illegal, it probably should be allowed. And then the strategy is this: the solution for bad speech is more speech, is good speech. If somebody's putting out a really terrible idea, then I'm going to put out a much better idea, at least in my view. And I let the audience decide. The people on social media are intelligent human beings, and they're responsible. They can decide. If they don't like it, they can turn it off. If they do like it, they can listen more. That is their choice. And I don't feel that some person at Twitter or some person at Facebook ought to be telling anyone what they should not be listening to.
Okay. And to go back to your premise now, let's take it full circle.
Sure.
Talk back about the future of IT. We've kind of hinted what your sort of viewpoint is with the way technology is, but talk about, I guess, the bookie system and where you kind of see technology or programming going in the future.
The bookie system?
The two booking system, the two booking system.
Oh, you mean double entry bookkeeping?
So, yes, double entry bookkeeping.
That's usually a reference I make when I'm talking about test-driven development. Is that where you're going with this?
Yes.
Oh, all right. We programmers would like to call ourselves professionals, but we profess nothing. We have no disciplines that we profess. We have no standards that we profess. We have no practices that we profess. We are not, therefore, professionals. How can we become professionals? Well, okay, we're going to have to figure out what to profess. Is there an ethics? Do we have an ethics of programming? That would be interesting. Yes, thank you, Siri, for defining ethics for me. Do we have an ethics? Can we come up with one that we can profess? Do we have a set of disciplines that we follow that are part of our profession? Do we have standards that we adhere to? Now, I like to think of test-driven development as one of those disciplines. And I like to think of it that way because we programmers have something in in kind with accountants. We, programmers, create documents, very, very complex documents full of bizarre symbology that no one else can read. And every symbol has to be correct. Otherwise, horrible things happen. Accountants have exactly the same problem. They produce documents, spreadsheets, books that are full of bizarre symbols that most people can't read and understand. They understand them just fine, but no one else can. And every symbol has to be correct. Otherwise, terrible things happen. They got the money not under control. You can send the executives to jail. You can put up against lawsuits. You can make the company go bankrupt. How do accountants deal with this problem that every symbol has to be correct in this arcane symbology that they manipulate? And they came up with a discipline. And it's a discipline that nowadays carries the force of law in all countries, I think. And it's called double entry bookkeeping. When you maintain a set of books, you enter every transaction twice, once on the asset side, once on the liability side. And they follow separate mathematical pathways until they wind up in a single subtraction on the balance sheet, and that subtraction must yield a zero. And the way that the accountants enter the transactions is one at a time. They enter a transaction on the asset side, and they do the sums. They enter the same transaction on the liability side. They do the sums. And then they subtract on the balance sheet, zero. Okay, nothing wrong. Next transaction. Asset, liability, sum it up, zero. Asset, liability, sum it up, zero. That's how they're trained to work. And this carries the force of law. We programmers don't do anything like that unless we're following a discipline like test-driven development. Test-driven development tells us that we should write a test before we write production code, and that the test should describe what the production code does, and then the production code will pass the test. And these are tiny little bits of code, 2 lines long, 3 lines long, little tiny bit of test code, little tiny bit of production code, and then it should compile and execute, and there's 0 defects. Little test, little code, execute, 0. Little test, little code, execute, 0. Same discipline, same reasoning. It doesn't carry the force of law, but it might one day, because the legislators are coming.
The legislators are coming. Interesting. Yeah, so essentially your premise is essentially if there isn't rules, this is very high level. If there isn't any rules to programming, then something catastrophic will happen, and that's when the lawmakers will be coming, essentially. More or less.
Yeah, I mean, it's not hard to imagine that. The catastrophes have already begun. We've had a number of fairly significant catastrophes, and the lawmakers have not yet stepped in. It got close once. You may remember the struggle over the American healthcare system back in 2008, 2009. And the Congress passed a law called the Affordable Care Act.
Mm-hmm.
Some people called it Obamacare. And the law said that a software system had to be in place by October 1st, 2013, I think. I think that was it. Well, that's an absurd thing to say. You can't pass a law that says that a software system is going to be in place, because, of course, it won't be, and it wasn't. And the software system failed horribly for several months. And for a very brief period of time, that catastrophe, the fact that the system wasn't in place, was so embarrassing to the administration that they considered a new cabinet position in reporting directly to the president, the CTO of the United States of America. And that just chilled me to the bone. What would that guy do? Given that government bureaucracies always grow endlessly, what would that CTO of the United States of America, what would that do? And fortunately, that did not happen. Since then, we've still had a number of catastrophes. People are killed routinely now by software that malfunctions. The software in their cars can malfunction. That's killed several dozen people. The software in airplanes malfunctions. That's killed several hundred people recently. Fortunes are lost by mismanaged financial software. The stakes are getting very high. The stakes weren't high 30 years ago. Software wasn't running in stuff that people used every single day. But now, no one in Western society can escape using a software system on a minute-by-minute basis. There's nothing you can do in our society without a software system. You can't call someone on the phone. You can't microwave a hot dog. You can't wash your clothes. You can't drive your car. Nothing happens in our society without software. And that opens up the possibility for real disaster, really big disaster. Now, I would have thought that maybe the 737 MAX thing would have triggered it, but it's in a niche that maybe won't trigger it. But at some point, some terrible thing is going to happen. Some poor software guy is going to do some dumb thing and kill 10,000 people. And that's when the legislators will come. And the legislators will ask us, how could you have let this happen? You guys, how could you have let this happen? 10,000 people are dead. And, all the programmers are going to say, it wasn't us, man. Like it was our boss. They told us it had to be done on Tuesday. So we got to get it done. And the legislators of the world will look with piteous eyes upon these poor misguided programmers and say, you don't understand. It was your fingers on the keyboard. You guys did this, and you didn't do anything to stop it. I think we need to do something to stop it before that happens.
So that's where the standard comes in, and eventually there will be laws, just like with the internet. There are laws. Some people argue, obviously, not good enough laws, but hopefully something in the future will come in to help resolve that situation.
Yeah, I don't want the laws. I'd much rather there not be laws. But I think the laws are inevitable because the stakes are so high. So what I do want are the standards and the ethics. And I want the standards and the ethics to be there before the laws get there. Because when the legislators do decide to legislate, to regulate the software industry, it would be a very good thing if the software people said, okay, well, here's our rules. Here's our standards, our ethics. Here's the practices. We don't mind if you make them laws because we're already following them. That's what the doctors did, right? The doctors had it all sewn up into a nice little bundle before the legislators got it. And then the legislators said, we got to regulate you guys. And the doctor said, well, here, take these rules.
It's interesting you say that, actually, because then I guess if going back to the internet, social media, do you reckon it was just too fast out there? There was not enough time for people to adopt a standard or rule when conducting yourself on like social media or just like the internet? Or do you feel like they did get it right? Or what's your thoughts in that? Like, I'm trying to see if there's a parallel between, the way software, our society works, and the wider internet, social media aspect in terms of the trajectory of them both.
It's a fascinating question, right? When programmers build software, they are creating machines that have certain behaviors. And those behaviors can have beneficial effects or terrible effects. People can die if you're controlling an airplane or a nuclear power plant or something like that. Social media is constructed out of software, it's true. But the behavior is only to allow people to communicate. Should that ability to communicate be constrained? And aside from the legal aspect, I say no. I don't want any constraint at all. I don't want to deal in a medium that is going to put a finger up to my mouth and say, well, you can't say that, so long as it's not illegal. So that's where I come down on this. I don't think there is a parallel between the possible things that a software system could do that were detrimental and the proper functioning of social media, which is to allow communication unconstrained.
Interesting. And yeah, that is, I think it's a good way to end that segment. I do have some like questions that just quick fire questions of favorite solid principle, for example. What is your favorite solid principle?
Do I have a favorite
Or
solid?
do you have one?
Evans. Um, the one that the one that shows up most often, the one that I look at code and say, well, that violates that principle, is the single responsibility principle. It is the it's not the most overriding principle. It's not the most important principle, but it is probably the most violated principle. Um, yeah, that's what I guess I'd say. A module of software should have one source of change, one group of users out there that request changes to it. We don't want to have two separate groups submitting changes to a single module, because then you can't satisfy anybody and you'll break one group when you try and get another group to work. So that's how I would like to, that's how I look at the single responsibility principle. And it is the one that is most frequently violated. If I look at code and I say, okay, is there a principle violated? 9 times out of 10, it's going to be the single responsibility principle.
Okay. A lot of people who maybe don't have the programming mindset, or maybe wasn't born with the acumen maybe to program, but are really driven and really interested in programming. What are some of your advice, or what would you say? You've got this interesting thing with katas, really. Maybe it's to do with that, but yeah, expand on what would you say? What's your advice to those sort of people?
Well, there are several bits of advice. Number one, many people get into programming because they think it is a 3 or 5 year thing that they can use to then get into management and so on. And if that's your goal, well, then fine, do that, and then get into management as soon as you can, because we probably don't want you actually programming anything. Then there are people who really want to be technical, and they want to stay technical. They want to stay technical for 20 or 30 years. And for those people, I suggest resist the draw towards management, because you will be drawn, and the pressure will get enormous. I have succumbed to that draw several times in my life, and always managed to make it back to be a programmer. Thank goodness. Read constantly. Do not think because you know Java or C# that you've hit the pinnacle and there's nothing else to know. There is a ton to know. Read like crazy. Read old stuff, right? Go back to these books that I pulled out here. Just a few of these books. Read those books. Here's a book I'll get out for you. Read this book. Read design patterns. Understand design patterns. This is the most important book written in the last 30 years, right? Make sure you know these design patterns. Understand them. Here's another book for you. It's Domain-Driven Design by Eric Evans. Understand what he says in here. It's fascinating and powerful, right? You've got to know this stuff. Acquiring the knowledge of and I've just pulled out, like 3 books out of 50. Acquiring the knowledge of software development is the work of a lifetime, and you will never get to the pinnacle. So you have to keep on climbing and keep on learning. But there's something else you have to do. It is very easy for programmers to get so focused on the code and on programming that they forget that their real purpose is to communicate. So you also have to practice communicating. This doesn't come naturally to most programmers. So you should practice it. Practice giving talks. Practice writing articles. You may never publish them. It doesn't matter. Write them. Practice writing. Practice articulating. Practice speaking. Get your coworkers and give them a little talk about something that you read about somewhere, or some new language. Develop the skill of communication with other people, and that will serve you very, very well.
Awesome. One Okay, yes. Another question, actually. This is more of a slightly technical question. So you've
Yeah.
got this book, right? I'm going to plug it a little bit. So you've
Oh
got
yeah, yeah,
this
yeah.
Clean Code.
Clean
And
code.
just to plug it a little bit, it's a fascinating book, and I definitely recommend anyone starting or anyone in general to read this book. It's fascinating. We've had many discussions on it. Do you want to quickly just give a highlight before I give you my question on Clean Code of what, the book is about?
Clean code is a book that I knew I wanted to write for 10 years and didn't think I ought to, because in the book I tell people what to do. And there was this mindset uh, long ago that you should never tell another programmer what to do. And at some point I just said, well, somebody's got to write this and I'm going to do it. In the book, I am opinionated. I tell you what to do. I let you know that these are my opinions and you don't actually have to do them, but I'm still very opinionated and I tell you exactly what to do. And I talk about how to write functions and how to name variables and how to separate things and how to write tests in extremely opinionated and very detailed form.
And it's interesting because for me, right, it's like a purist book, right? It's a very purist book, and a lot of people, if reading that, it's cool to read. You learn a lot, but then you go into industries and you see it's not as pure. And so
Yeah.
one of my question is when you talked about design patterns and applying like domain-driven design, for example, and you get to a stage where there's a conflict between clean code. So for example, you've got an object, a domain. It makes sense in the domain aspect, but however, from a clean code perspective, you might feel like you need to break down your object. So for example, let's say we've got a school application and you've got like a student object. It makes sense, but when you look at some of the properties, you see something like address and you look at that and think, okay, from a clean code perspective, you need to break that down a bit more. However, from a domain perspective, it makes sense. Is there a line where you can kind of please both sides? You can still keep it clean, but at the same time, your domain still makes sense. Thoughts?
This is the purpose of abstraction in software. And I would go so far as to say that's the purpose of objects, the polymorphic boundaries of object-oriented programming. It is possible, if you are skilled enough, to create abstract barriers that keep the domain stuff completely isolated from the dirty little details that you've got to program in. And if you know how to route your dependencies properly and how to use polymorphic boundaries to do that, then the question that you posed as a dilemma is no longer a dilemma, because you've got this boundary that separates the domain from the implementation in a very significant way.
Okay, awesome. Thank you. Before we wrap up, just want to say, what is next for you? Do you have anything coming up? Are you writing anything? Are you doing a course, for example? I've got one question saying, are you going to do a clean code course on like, Pluralsight, Udemy, all those sort of things? Is there plans for a podcast? I know this is something we've talked about, offline, should we say? So what's going on? Like,
Oh,
what is
there are
happening?
many, many plans. I have two more books I need to write. The first one is in progress now, and the second one will come a few years later. It always takes a couple of years to write a book. I am
Any
doing
teaser on what it's about?
the first one is going to be something about clean practices.
Okay.
I don't know what the title is yet, but something like that. And then the one after that will be on the ethics and standards. And I think that will complete all the books I need to write. We'll see. I do a lot of videos. Those videos are on cleancoders.com. And there's a ton of them out there that talk about all the principles and patterns and Agile and everything else, functional programming, everything else. Tons and tons of video out there, at least 70 or 80 hours worth. I have classes all the time. So if you go to my website, which is cleancoder.com, without the S, you can see all the courses I'm going to be teaching and when and where. You'll see them on the site there. And am I going to be doing a podcast? Well, I do other people's podcasts all the time. So I'm doing yours. I do a lot of others. I'm very happy to do those. I am contemplating doing a set of videos, kind of like maybe a YouTube channel on both software and aviation.
Okay.
I'm not quite sure how I'm going to put that together, but
Interesting mix, yeah. Awesome. Okay. And let me see. One last question before we wrap up. Have you changed your position on something? And if so, what is that thing that you've changed your position on from?
Probably the biggest change that I've gone through over the last 35 to 40 years is my position on high-level languages. I used to believe that high-level languages were wasteful, and that if you wanted the best performance possible, you would use assembly language. And in those days, I was an assembly language programmer. That's just the way I worked. I saw a hint that might not be so way the heck back in the 70s when I first started programming C. C is assembly language. It's just slightly higher level. And then bit by bit over the years, I've backed off that position as I watched really very competent compilers compile programs down into machine code that executes even faster than I could make machine code execute, which blows my mind. The last change that occurred along those lines to me was when I finally gave up and said, yes, Lisp is actually a pretty good language. Because I fought that like hell. I didn't want to do all those parentheses. And then finally I read a very good book. Let's see, I can get this book down, can't I? Where is that book? Oh, here it is. The Structure and Interpretation of Computer Programs. And that one I read about 10 years ago now, and it convinced me. Now I have to learn Lisp. I have to understand Lisp. And that's the reason I became a closure programmer. I think that when all the dust settles and all the languages finally peter out, Lisp will be the last language left. It's the language we're all going to wind up using one day. That's what I think. So, by the way, this book is free. You can get it on the internet. The PDFs are all up there. So you don't have to buy it anymore. And the videos of these guys teaching their course at MIT are also up on the internet. So watch those videos. They're fascinating.
Awesome. All right. I think we're good here, I think that was an interesting conversation. Is there anything that, before we wrap up, you want to mention, something you feel like we might have missed, or anything you just really want to plug, really?
No, I think I plugged all the websites and stuff.
Yeah.
I sure did enjoy this. Thank you so much.
Yeah, no, it was great. It was awesome. I mean, every time we've met in the past, it's always been interesting. It's always been fascinating. So, obviously, it's always great, and obviously happy to do this again. Obviously, when you're down in London, to link up, how it goes. So, yeah, no, definitely. This might even be a part one. Who knows? But we'll see what the future holds. Yeah, I want to say thank you again, and watch this space. Everyone knows where to reach you. Is it Uncle Bob, or is it Uncle Bob Martin at Twitter?
Oh, Twitter, it's Uncle Bob Martin.
Uncle Bob Martin, and I think you're not on Instagram or anything like that, are you?
I'm not. No, I never did get onto Instagram.
No. Cool.
No.
Awesome. Not Snapchat. Are you on Snapchat?
I got on Snapchat either.
No. Okay. That's fine.
I too.
Okay, awesome. All right. Thank you, Bob. And I'm going to stop recording now. This is a SkillStruct presentation. If you like what you hear and see, don't forget to like, share, and subscribe.